Okay, and welcome back to episode 8 of Trying to Draw a Triangle. It's been a fair while since I got back to this, so I'm going to have to remind myself where I was up to, but I think where we're up to is we've got command pool made, and we now need to work out what commands we need to actually fire off, and how we go about doing that. So let's go have a quick look then. Let's do our normal bits, so make this. I'm still playing with Cocoon. I'm actually quite enjoying Cocoon so far, so I think I'm going to stick with it for now. I found one thing that helps is doing it kind of like demonized client server mode, so that you can exit out and come back into the same thing quickly. What do I call this? I'll call it Flectris. There we go. Let's do that. And then we'll connect into it. Right. So, where would we have been looking? I guess we're getting to the point now where inside of our main file, down here somewhere, we're going to have a draw frame. And draw frame is our to-do next. And if I just do a quick check, did I have any other to-dos? Okay, there's at least one. What was this one saying? About presentable image formats. Okay, so that might become relevant to us any minute now. But where we're up to, we want to work out what we do on draw frame. Just to doubly check, excuse me, in renderer. I'm already in renderer. We have made our command buffer. If I do a quick search, we are actually like initializing it and everything, right? Yeah, we allocate it. I'm guessing that's all you need to do, because the command pool, I guess, does all the managing, the sort of like instance of it. Is that true? I wonder if that's true. God, it's been a little while. So the command pool is attached to a queue family index. I'm guessing that's how this works. So I guess we will submit work. No, because you do have to record things in the command buffer. We must have a handle on the command buffer. I'm losing it, aren't I? Allocate command buffers. Has a pointer to render a command buffer. Yeah, so we totally have a handle, which is good because I think we're about to need that. So if we go and look in here, I think the first thing we want, we're gonna have to call this begin command buffer and end command buffer, which I think you do at the start and finish of each command buffer that you actually want to record. So if we come into here, what does this say? Use the command buffer we've just allocated to record draw commands, record our draw command, submit our draw command, and a question mark about how we do synchronization, because I don't actually know what we're going to need to do. Okay, cool. I think we can take all that out, and I think the first thing to do is either begin command buffer. We will pass into that our renderer. Is it a pointer? It's not a pointer. Our command buffer, and it takes a pointer to begin info. That's interesting. I don't expect that. And it can fail, so let's go ahead and do our normal little song and dance. If res is not success. Wrong thing. That's interesting. So if you're just after it, select around word doesn't work. I can do back though. Okay. Learning the Cocoon keybinds that are like just different enough from the Vim ones that it's going to take a bit of getting used to. What is this begin info? Does this say anything? Pointer about additional information for how it begins recording, which doesn't tell us a lot. We can see what it looks like down here though. It takes inheritance info and flags. So I don't think we're going to have inheritance info, but I guess we'll have a quick check. The flags might be interesting though. In normal Vulkan fashion, we need to have an S-type. I guess it's begin. Nope. Just command buffer begin. Command buffer. Oh, is the LSP not going to catch it for me? Command buffer begin info. Do I need to make it capital? Why is caps lock not working? Damn it. Oh, that one. Command buffer. Kind of annoyed that's working like this. Is it because I've not defined a begin info there? Ah, that's interesting. So is LSP just crashing and not bothering to get down that far? No, I'm just an idiot. I'm jumping the gun. Christ. You tell I am tired. It's been one of those weeks. So we're going to say in this case we panic, and what do? We print failed to begin command buffer. Up here we will make a begin info, which will be a VK command buffer begin info, and around that I'm putting semicolons after everything. I actually think it's not needed because it's Odin. Do you know the other problem for this? So I've had a busy enough week. I've not had a chance to get back to the stream and to sort of spend the time to dig into this, but I have been writing a little bit of just like data structure and algorithm stuff. Just I don't know, fill a half hour here and there in the evening. So I think I've got C in my fingers now. So if you see me type some weird stuff, that might be it. Or it might just be delirious tiredness. We'll see if this evolves. This has all been quite minor so far, though. We can get on with this. So this is a command buffer allocate info. Then P next, I'm hoping we don't need. Flags is always worth a look. And inheritance info is worth a read at least. Right, so flags is a bit mask of these things. What are these things? One-time usage, render pass continue bit, or usage simultaneous use. So one-time submit specifies that each recording of the command buffer will only be submitted once, and the command buffer will be reset and recorded again between each submission. I think... Is that us? I think that is us. Right, because we are doing a new recording on each draw frame. And we did have to set something. Was it on the command pool? There must be a quicker way to find that. Let's go command pool. This is the problem with the screen being so small, you can't actually read anything. Okay, let's try this. Command pool. Is it you? There. Yeah, we made this flag reset command buffer that we can't jump to. I'm reasonably sure what this was us saying that the command buffer will automatically do the reset for us if we resubmit a queue. So even that's not what we're doing. So actually maybe that could be, because I think one of these is like transient value or something, isn't it? If I go in here, yeah, that can be transient. Okay. That's an interesting point. So I think the way we're writing this for now, this will be transient. We only ever make one-off commands. We record the command, we send the command. We come to another one, we record a command, we send a command. Does it mean if the buffer is transient though, not if the command is? Because that makes more sense, right? Okay, I'm going to leave that as it is. I think I'm overthinking it. Whereas this one is one type submit, because each recording of the command buffer will be submitted once. The command buffer will be reset and record again between each submission. So yeah, I think that is us. And that flag for the reset bit means that each time we call begin rendering, it will do the reset for us. Or begin recording. Okay. So that was the flags. No, I've done this wrong. Where even were we? We were in here. Then we were in here. We were looking at the flags. Inheritance info is a pointer to a struct used if command buffer is a secondary thing. So we don't need that because we are not a secondary command, because that's a command buffer being called from another command. We aren't doing anything that complicated yet. I'm guessing the next thing we should see is going to be the stop command recording call. That basically our entire draw frame needs to be wrapped in. What does this say? Attachment. What is this? Maybe I shouldn't assume that. One buffer inheritance. Rendering info sounds like we aren't going to need it because it sounds like it's secondary stuff again, but let's have a look. Part of the execute of VK command, execute commands command. Yeah, that's about secondaries, isn't it? That's how you dispatch a secondary command, I think. Okay, so we're going to scroll till we see the stop. Hey. What does this up here say? Once the recording starts, an application records a sequence of commands, which you can recognise by VK command, to set the state in the command buffer, draw, dispatch, and other commands. Several commands can also be recorded indirectly from VK buffer content. Interesting. Probably complicated. To complete recording of command buffer, you call this thing. So we're up here. That also has a result. Interesting. So end. We'll call it end res. Which means actually we probably do need to give that a better name, don't we? Let's call it begin res. And then end res. This is likely to be quite a long function, is it? Should I actually, instead of that, should I do the same thing I've been doing before? So again, this is something that I guess is slightly odd. But I've been doing it so far and quite enjoying it. Is instead of breaking things out into functions, I've been just using little scopes. Actually, particularly neatly in other editors where you've got code folding, you can then fold the scopes to make stuff that you're not interested in at the minute collapse away. Then you can expand things out when you get stuck, because I don't understand Vulkan really at all well. So it's useful to be able to just kind of see things top to bottom and read it like a book. You know, jumping to one function is never too bad, but once you get functions calling functions, I don't know. I found the extra overhead just made life that little bit too hard for me. So, and the other thing that's nice about it is it means that these names can be kind of rubbish or very generic, right? So like res for a result. There's going to be a bunch of results in draw frame. So one reason to pull things out into functions is it avoids the naming collisions and the potential bugs that come with that. But again, I'm probably overthinking. But I found this works for me so far for like small projects where I don't really understand things well. So let's stick with this for now. So what we're actually doing in here, this is going to be begin recording commands. And then we can leave our really generic sounding names. And then down here, we're going to have end recording commands. The other thing that's nice, I found doing it this way, you do this, you discover that actually I did want that to be a reusable function. Because it's already in a scope, you kind of already know that you're not relying on anything global that you're going to have to worry about passing in, or it's very clear what those things are. So you literally just, you just yoink this block out, and it is the function block already. So I don't think there's any real cost to doing it this way, which is nice. What does this thing do then? So end command buffer. Oh, it literally just takes a command buffer. Cool. But it can finish. It can fail. So let's go vkres end command buffer. Again with a semicolon, not needed. This is going to be our file renderer. And if res is not a success, oops. What button is it? It's that one, isn't it? Still getting these key mapped into my hands. If it's not that, blow up and make it really easy for future me to see where it blew up. Fail to enter command buffer. Right, is this interesting? The command buffer must have been in the recording state, and if successful, is moved to the whoopsie daisy. Moved to the executable state. Have we read about this already? Okay, cool. So, yeah, executable means exactly what we think it's going to mean. At that point, we can submit. So actually, that's a good thing to know. Submission comes down here. You submit, you record the buffer, then you submit it. Submission isn't a command in the buffer. Which makes sense, actually, now I think about it. If there was an error during this, the application will be notified by an unsuccessful return value code, and you move to an invalid state, which we won't be handling. We're just going to blow up. In case the application recorded one or more video encode operations, they may return error invalid video std parameters. Any of these things, but so we're not doing video encoding, so we don't need to worry. Sorry. Oh. Thump the mic. You can tell I'm still a noob. Not used to this. Okay. Cool. And then what's this? To submit a command buffer to a queue, call one of these two. Curious what the 2 gives us. A submit count, p submits, an offense. Is he going to tell me? So I paused only because normally when you see these 2s, what you see is that they've included a pnext field. So I think they had quite a lot of calls. I guess in version 1.0, they underestimated how much they would need to extend things, and so they've had to make version 2s for certain functions to add the kind of extension pointer. It's interesting this doesn't have one. So what is this saying? Q is the queue the command buffer will be submitted to. Submit count is the number of elements in the p submits array. P submits a pointer to an array of structs. Each specified command buffer submission patch. Command buffers and semaphores specified in this array may be accessed at any point until the queue operations they define complete execution. And this is one of our synchronization things. Offense to be signaled once all submitted command buffers have completed. So this is about batching, right? So a major bottleneck in programs that are using a CPU and GPU is the point where they have to communicate back and forth. So this submission is the point where we're gonna batch work and send it from the CPU to the GPU. So if you were doing something big and complicated, it's a good idea to batch things into one big lump that you send at once. So I guess this is saying the fence, if I send a batch of work, the fence will alert the CPU when the whole batch has been done. It's kind of like using an await, right? You're going to use the fence to block and wait for the GPU to finish. Why is this saying? Semaphore operations submitted with VKQ submit 2 have additional ordering constraints compared with other submission commands, with dependencies involving previous and subsequent queue operations. Alright. Which I guess makes sense, right? Saying, I think what that's saying is that if I submit a bunch of commands and later commands depend on earlier commands, then there are constraints about how things are ordered, which is controlled with semaphores, which makes sense. So in our case, what would that mean? I don't know. I don't think we're doing anything complicated enough for it to affect us. But like as an example, if we... I don't even have an example. Yeah. No, I've got nothing. The problem. I'm trying to talk about something you know so little about. If any command buffer submitted to the queue is in the executable state, it is moved to the pending state. Once execution of all submissions of a command buffer is complete, it moves from pending back to executable. If it was recorded in the one-time bit, it moves instead to invalid. So that's us. Right, we're only going to submit this one time and then we move it to invalid. We never reuse it. If this fails, it returns an error. Cool. We're not handling the errors, we're just going to crash, so we don't care particularly. Submit info 2. So a wait semaphore count, there's wait semaphore, the command buffer info count. Pointer, so this is our list of command buffers. And signal semaphore. Ah, okay. So a wait semaphore says this can't run until this semaphore gets signaled, and the signal semaphore with the things that this command. What's it by? It's on submission though. So I guess it's done by index, is it? So if I have 3 jobs, and they need to order 0, then 1, then 2. I guess what we'll have is a wait semaphore on indexes 1 and 2, and signal semaphores on indexes 0 and 1, and those semaphores must, I guess, have information to say which one they're pointing to, but... Yeah, struggling to keep this all in my head. So what does this say? Submit flags, wait semaphores, a pointer to an array of semaphore submit info structures defining wait operations. I actually think in the very first thing we do, we might get away without any of these. Because we're literally just going to be like, don't care. Just read the vertex buffer on each frame and you get what you get. Bits which can be set in this, specifying submission behavior, or the equivalent, submit bit flags, semaphore submit info. Ah. What is a stage mask? Mask of pipeline stages which limit the first synchronization scope of a semaphore signal operation. We're totally going to have to go read this semaphore wait operation stuff, aren't we? Index of the device within a device group. So we're not using device groups, so we don't care. Command buffer submit info. Where's device mask in this? Which device in device group? So again, don't care. Render pass, stripe, submit info, arm. Ah, okay. Fun. We're down to the old one. Did anything say? So what's the difference? This one just has submit info. Can I stick a bookmark on here so we can get back to it easily? Apparently you don't do that with a right click, because I thought you did. Ugh. Alright, I'm just going to remember what page it is. I'm going to scribble it down. It's 271. Hey? Okay, it's 271. And that has queue submit count. In fact, let me copy that. We'll go stick it in yeah. What did the other one have? Spend all that time getting through it. Just scroll straight back up to it. Queue submit 2 has a queue, a submit count, P submits and fence. You don't look any different. Are the types different? Ah, submit info 2. So the interesting bits in submit info. So this is structured differently. So let's doot. What do I do there? They're the old ones, right? And then it was back down to page 271. So this guy takes version 1 of this, which, oh, this is formatted horribly. Okay, so let's go delete that, delete that. Oh, it's the types are all mangled. Yeah, it's giving me all the types first. Okay, let's hope we get away without them. So it has S type, P next, flags. Do we not have flags on this one? We don't have flags on this one. Wait semaphore, P wait. Ooh, pipeline stage flags is missing from this one. In command buffer info, P command buffers, and signal semaphore. So that's the difference. Is this is missing. It's a pointer to an array of pipeline stages at which each corresponding semaphore wait will occur. Okay. So I guess we just need to decide which one of these we're going to use. It looks like, are these all added in v1.3? It looks like they were. So I'm guessing these have been written with dynamic rendering in mind. And we are using dynamic rendering when we get there. So, I guess we do this one. So we're in here. Check my brackets make sense. Let's go ahead and do it like that. Do we just put the submit in? We'll record the commands after. I think we put this in, we'll run it, and we'll see if we get a load of validation errors. We might get validation errors about submitting an empty command buffer, but I think if that happens, that's kind of fine. So it'd be VK. You also end up generating a result. So Q submit to. You require a queue, which lives on our renderer. You require submit count and submits, where submits is an array of structs, each specifying a command buffer submission batch. So we're going to have one. We're going to have an and submit info that we'll define in a minute. And fence is an optional handle. So that's a to-do. To synchronize with host. So I think we are going to need this. So this is, while we're doing one frame in flight, we're going to have the CPU do some work to generate a game state, generate our drawing data, send that to the GPU, and then it's going to wait until it hears back from the GPU to say I'm finished. And this is what this fence does. But let's worry about that later. Let's just see a triangle before we worry too much about how we synchronize. VK result. All this stuff, so we need to submit info. So submit info is equal to VK submit info 2. What does it say down here? The queue submission command with each batch defined by an element of p submits, semaphore operations within the things. Okay, we read that. At least I think we did. Let's see what's on this. Submit info 2. Sorry, my throat's going. Oh dear. Right, so we have our obligatory S type, which will be submit info to, submit, submit info to. And then we can get rid of this. Can I remember the keybind? I can. Oh, I'm never used to that though. So, one of the things I'm finding with Cocoon, it lets you go like to this position one past the end. I'm fairly sure in Vim you couldn't. Or at least you could once you were into like insertion mode, but in normal mode, I think Vim would just block you on this last character. So I'm really used to navigating to the end of a line. So like jump to the end of the line. Ah, interesting. Okay, it didn't do what I thought it would do. I guess if you're typing, is that it? So if I'm typing this out, yeah, it puts you at the end. Then when you hit escape, it stays there. Then when you hit A to add to the end of the line, it actually drops you to the next line. So I guess it's saying like I'm appending after the like implicit like new line character that you're actually sat on. But I'm sure in time the muscle memory will sink in. Or I'll get sick of Cocoon and I'll stop worrying about it. They're the options. Flags we will worry about in a bit. I might just put all of these in so that when we're debugging later, I remember they're here. But I don't actually know what to put in these yet. So we've not made any of these semaphores or anything yet. Ooh. Twitch says I'm having network trouble. Twitch lied. Okay. What was I saying? Yeah, I'm going to just put all of these in. Is it nil? Yeah. Just so that if and when things inevitably break, it's very obvious where I need to come back to. So we don't know what to do with the semaphores yet. We know what we're going to do with our command buffers is... we don't actually know what we're going to do with our command buffers because it's not a command buffer we point to, it's command buffer info. So let's go ahead and just add that in here. And just for prosperity. Prosperity? What's the word I'm looking for? It's not prosperity. The word that means like for the historical benefit. It's gone. It's not in my head. Command buffer info, which is going to be a VK command buffer submit info, which is yet another to do. Don't you love writing Vulkan? Command buffer info count, command buffer infos, and then yeah, these signals. I just don't know what to do with them yet, so we will put them in. So when it breaks, I remember they're there. So that's our submit info, which we're still missing our command buffer info. We're going to start on the command buffer because I know what command buffer I'm going to try and submit. And so command buffer info looks nice and easy. So we come in here, it's another S type for a command buffer submit info. Does it need to be KHR? I don't think so, because it's been promoted, hasn't it? Why has it kicked me to the bottom of the screen? Can I navigate back to it like this? No. What did I do? Okay. So command buffer, submit info. P next, we're going to hope to not need. Command buffer, we set to our command buffer we made on our renderer. And device mask, I think it was saying you set it to 0 and it's the same as just saying for everything. So yeah, so device mask is useful if we have a device group, so we're using multiple, I guess, bits of hardware to run our graphics pipeline, and we ain't doing that, at least not yet. So cool, I think that should work. It doesn't draw anything yet. It doesn't actually submit anything, but I think that submission stuff should all compile at least. Have I made a make file? I've not made a make file. So we're going to just have to do Odin run main. Cool. Okay, so we get a bunch of validation errors. Oh, okay. I was going to say let's find the first one, but presumably we get one per draw frame. What are you saying? Begin info must be VK structure type command buffer begin info. Did I just assign the wrong one? It's the begin info up here. I did just assign the wrong one. Command buffer begin info. So let's clear that mess off. Try again. And again, let's get the first one. Q submit to synchronization. Synchronization 2. Feature must be enabled. Interesting. And what are you saying down here? On an active command buffer before it's completed. You must check command buffer fence before this call. Cool. Okay. Yeah, that makes sense. Do you know what I might do? Is just in the run up before we... So we are going to need to do synchronization so that we don't hit exactly this trouble. So what this is doing is basically it's running very, very quickly on the host, because the host is basically doing nothing. It submits the command, it then submits another command. And because we've not implemented any of our what's it called? We've not implemented any synchronization yet. The command is in progress, and we're already trying to submit another command to it, and so it's correctly blowing up. I'll stick a break in there, so we're essentially going to just render one frame. Yeah. Let's see what you do. Cool, so when you get the one now, synchronization 2 feature is not enabled. Synchronization 2 feature must be enabled. Is that something I should have seen back up here? Was it further up where I didn't bother reading? Command buffer submission. Work in as few calls as possible to submit. Let me get rid of you. In fact, can I just get you off the screen? To submit command buffers to a thing, do this. Was it saying needs to be enabled? Synchronization 2. Which I guess is this business, is it? I'll see what I'll do. We'll just Control F for synchronize. Is it synchronize with a Z? Synchronization 2. Cool. I should have seen that then. Ah, no, but I'm using 1.3. So if we go back to renderer, who's using KHR when they shouldn't be? Destroy surface KHR. Make swap chain images. Okay, so notice it's not saying anything about an extension, it's just saying something about a feature. So I guess maybe that's different than what I'm thinking about. Because you notice, so none of the calls I'm making, unless I'm about to be wrong, like there is here KHR. Let's see, if I do that, that should compile, and then does it blow up its seg faults? Presumably because it fails to find the KHR function? Maybe? What do I get if I do that? And then submit info is the wrong type. Why are you the wrong type? Submit info 2 is what we've been looking at. I kind of wish they gave you a little paragraph to tell you, like, up front why they've switched from one of these to the other. Okay, so the old submit to a queue, a submit count, and P submits, and a fence. That's exactly the same. And submit info takes type P next, wait semaphore count P waits. Which one of these was different? It was this one. Wait dest stage mask. Okay, hang on. So do you need to be that? No. Oh, I'm confused. So this other one doesn't take the same type, and yet, if I'm reading it right, those two do take the same type. So I've messed something up. Ah, and it's because that one is provided by synchronization 2. But that is provided by 1.3, and we're using 1.3. BK submit info. Ah, it's because that one is submit info. What have I done that's made that angry then? So that is still fine. And it's that you would now be the other type. And now everything in here blows up. Can I jump to you? So S type. It's got no flags. What's your problem? Unknown thing for wait semaphore info count. So you just take wait semaphore count and wait semaphores directly. You take pipeline stage flags. Okay. I don't know anything about synchronization 2. So we're just going to bail to synchronization 1. I don't see anything telling me that this is explicitly a dynamic rendering thing. Looking at how it's structured, I'm guessing it's something about the semaphores and how you use them, which hopefully doesn't bite us too badly, because what we're doing is, again, going to be super simple. So yeah, let's just bump down to the V1 version, which should just be supported everywhere. And at least we don't have to go enable another feature for it. Okay. Submit info. We have a type which now submit info. P next we hope to get away with. We're going to have a wait semaphore count which is currently 0. But will almost certainly end up non-zero. We're going to have a command buffer count which will be 1. Ah, and it does just take a pointer to command buffers. Interesting. Okay, so you can literally just be a pointer to render a command buffer. I have to give you a name. P command buffers. Wait destination stage mask we missed. We don't know what that is yet. Command buffers, and then we have signal semaphore count is currently 0, and P signal semaphores is nil. We run U, and we don't get any validation errors. Nice. We are going to have to do a bit of reading though, because I don't know what some of these things are. So, again, is it a list of semaphores? Yeah, it's a list of semaphores. And a list of these destination stage masks. Where is DST? Okay. So what do you do? Wait semaphore count is the number of semaphores upon which to wait before executing the command buffers in the batch. And then the pointer is a pointer to an array of semaphore handles upon which to wait before the command buffers for this batch begin execution. If semaphores to wait on are provided, they define a semaphore wait operation. This is a pointer to an array of pipeline stages at which each corresponding semaphore wait will occur. Okay. Okay, interesting. Then you have your command buffers, and you have signal semaphore count is the number of semaphores to be signaled once commands specified in P command buffers have completed execution. And signal semaphores is a pointer to an array of VK semaphore handles which will be signaled when the command buffers for this batch have completed execution. A pointer to an array of semaphore handles which will be signaled when the command buffers for this batch have completed execution. If semaphores to be signaled are provided, they define a semaphore signal operation. Ah, are they not attached to individual commands within this? They attached to the entire buffer submission. But there's multiple because this buffer submission might require multiple other things that it's waiting on or have to alert multiple other things. That might make more sense than what I was thinking. Because I was trying to think if it was about synchronizing different commands within this command buffer. That is hard to see how they actually link up, but I think that does make sense. Okay. If it's that, these might actually just remain empty for our thing for now, because we're just going to submit the one command to say, I've got a buffer of triangle data, draw it. What does this say? The order that command buffers appear in this is used to determine submission order, and thus all implicit ordering guarantees that respect it. Other than these implicit ordering guarantees and any explicit synchronization primitives, these command buffers may overlap or otherwise execute out of order, because we're submitting to the graphics card to do things very, very parallelized. What are you saying? Timeline semaphore submit info. Okay, we're not making semaphores yet, so let's not worry about that. VK D3D12. Okay, we're not doing direct 3D, so we're going to not care. Right. I think we might be done with the kind of command stuff. I think we may have done the kind of like bits we need to do, yeah, around actually like physically shunting work to the GPU. I think we then need to have a look. So I think there is a chapter about drawing commands. We're basically going to have to look in here and work out what commands we do to say, now I'm going to go and draw. So I have a vertex buffer that is loaded with data already. So if I go back to main, right at the top of this, I've hard-coded this for now. So later we'll have a game state that will generate out this data essentially. It'll get more complicated before we get there, because instead of vertices, we'll have vertices and indices to sort of make drawing rectangles a little bit more sensible. But still nice and simple. But basically what I've got is I've copied this over to some memory mapped region on the graphics card. And so, yeah, I think we now need to just work out how to say, I want to submit a draw command pointing at a particular vertex buffer and making use of the shader code that we've already created. So this might be a good time to take a quick break. I don't know if you can hear my throat is going. I've just been croaking away. So I'm going to go grab a drink real quick. I have found every time I leave, though, I forget immediately what I'm going to do next. So inside of this, we'll have a... Is it that way around? No, it's not that way around. It's that way around. BRB... What's our to do next? Is Chat 22 would work out how to draw a thing. Cool. If that's not super difficult, we might actually get to a triangle. That would make me very happy. But I will be back in a minute. Okay, and I am back. Oh, I don't know what it is. It feels like it should be the weekend. Oh, shattered. But we're having fun. We're nearly at a triangle. Right, let's read the docs. So, drawing commands provoke work in a graphics pipeline. Drawing commands are recorded into a command buffer. When executed by a queue, will produce work which executes according to the bound graphics pipeline, or if the shader object feature is enabled, any shader object bound to graphics stages. A graphics pipeline, or a combination of one or more graphics shader objects, must be bound to a command buffer before any drawing commands are recorded. I would just like to sense check. I did make a graphics pipeline, didn't I? Yeah. It's the problem with these things being so spread out. It's funny because I think where this is taken like 8 videos to do, and they're all like an hour long, it's funny to pause and be like, that's like one day's actual work. If this weren't like a little hobby project, you'd be flying along. But, and I don't think it's quite that, it's not like a one-to-one where you can just say like, it would be this many hours of work. Because I think you have, with the stop-start, you have to keep reminding yourself what you were doing, so you never quite get in the same groove. So this has felt very slow, but hey, life is busy. So we've got our graphics pipeline. Is it a graphics pipeline or a combination of one or more graphic shaders must be bound to a command buffer before any drawing commands are recorded in that command buffer. Interesting. So we are going to need to bind. Do we do that in draw frame or do we do that in on initialization? Okay, so that's a decision to make. To do bind graphics buffer to command buffer here or in, yeah, in init. Probably needs to go into init, right? Because we're going to do it once and then we're going to use that same command buffer round and round. Each draw is made up of 0 more vertices and 0 more instances, which are processed by the device and result in the assembly of primitives. Primitives are assembled according to the input assembly state, which is a type of this. We did this, didn't we? If I go to input, no? Is it case sensitive? Input assembly state create info. Yeah, we did this. And, oh, I should have kept that, shouldn't I? Input assembly state create info, we make triangle list. As we're about to find out if that was the right choice. Restarting discards. I don't think we need that because we're not doing anything complicated that does that assembling. Pipeline input assembly state create flags. To dynamically control whether a special vertex index value is treated, call this, we don't care. Primitive topologies determine how consecutive vertices are organized into primitives and determines the type of primitive that is used at the beginning of the graphics pipeline. And determines the type of primitive that is used at the beginning of the graphics. Okay. The effective topology for later stages of the pipeline is altered by tessellation or geometry shading if either is in use and depends on the execution modes of those shaders. If in the case of mesh shading, the only effective topology is defined by the execution mode of the mesh shader. Primitive topologies include, where would it be? Triangle list specifies a series of separate triangle primitives. what is this? Each primitive topology and its construction list from a list of vertices is described in detail below with a supporting diagram and according to the following key. Again, if you want to, you can do it dynamically. We're not doing it dynamically in this case. Maybe this is a thing we should come back and do one day, is go back and do just everything dynamically. I think that gives it much more of a like OpenGL feel. I've not done a lot of OpenGL, but I think the little bit that I have done, I think OpenGL basically works like Vulkan dynamic rendering, where it's got a state machine it kind of sets up for you, and then you just tweak the bits you need as and when you need them. What is this? Topology class. Ours is triangle. And it's going to tell us how it does that assembling, which I guess is interesting, but I don't think we need to care at this point. I'm kind of keen to get to the point where we have something showing on screen, so I'm just going to skim all of this for now, but it's nice to know it's in there. Primitive order. Primitives generated by drawing commands progress through the stages of the graphics pipeline in primitive order. Primitive order is initially determined the following way. Submission order determines initial ordering for indirect drawing commands. Order in which accessed instances. If a drawing command includes multiple instances, the order in which instances are executed from lower numbered instances to higher. Oh. Okay, this feels like a lot of detail that I don't need to care about at the minute. It's used later to define rasterization order. Okay. Programmable primitive shading. There we go, vertex shading. So, that's the first stage we've written and we care about. Once primitives are assembled, they proceed to the vertex shading stage of the pipeline. If the draw includes multiple instances, then the set of primitives is sent to the vertex shading stage multiple times, once for each instance. Ah, interesting, okay. Okay, that's cool. So yeah, we super don't care, because we're going to have one instance. It is implementation dependent whether vertex shading occurs on vertices that are discarded as part of incomplete primitives. Again, don't care, because we aren't using that reset thing. Vertex shading receives 2 per vertex inputs from the primitive assembly stage, the vertex index and the instance index. How these values are generated is defined below with each command. Drawing commands fall roughly into 2 categories. Non-index drawing. Ah, okay. This is instance index. Is the instance it's talking about up here. Okay. Non-index drawing commands present a sequential vertex index to the vertex shader. The sequential index is generated automatically by the device. For details on both specifying the vertex attributes indexed by this as well as binding vertex, see these commands. I think we're just going to call VK command draw. And then later, we're going to call VK command draw indexed. Cool. I don't know if it's worth a little chat about what index buffers are. I guess we'll get to it later. It's a way of like reusing vertices so that you don't have to keep repeating them. So if you imagine like a square is made up of 2 triangles, the 2 triangles share 2 vertices. So instead of drawing 6 vertices, you can draw 4 vertices and then use a list of indices to point to them. So we don't care about an index buffer yet. We are going to care about binding a vertex buffer, assuming that's the way we're going. Interesting. There was nothing about a vertex buffer. That feels surprising. That feels a bit of a head scratcher. Have I just missed it? Buffer being bound, bunch of stuff. Index buffer, index buffer. No, it looks like it just goes straight on to draw. Maybe it says about it after draw. Okay. What is this? These parameters, indirect drawing commands. We will care when we need to. Ah, you need the vertex count. The index of the first vertex to draw. Okay, I guess we just start writing stuff. So, we're in here. We have begun our command buffer. We would like to do a draw command. So we come into here, and we're going to do vk command draw. It can't fail, because it doesn't return a result. It just takes a command buffer. In fact, let me just pop it on multiple lines. It's going to be long. Vertex count. I am not actually sure. Oh, let me do... Sorry. You'd have thought by now I'd remember how to do this. Do this one. We do vertex count is equal to something, but we don't know what. We definitely have that number somewhere. What's the matter with you? Instance count. Oh, okay, yeah, we're getting there. Instance count, I think it's 1. Number of instances to draw. We're just doing the 1 first vertex. Index 0, first instance will be index 0. So I'm assuming before we do that up here, we're going to have to bind vertex buffer. Presumably. Christ. Are there? Pull that up. When the command is executed, primitives are assembled using the current primitive topology and vertex count. Ah, does it? So the vertices are read in earlier than the draw command, because they have to go pass through the... Oh, I don't even know. Okay. We might have to go back and read some bits about that assembly, input assembly stuff. When the command is executed, primitives are assembled using the current primitive topology, which we're happy with, and vertex count. Oh my god, does the graphics pipeline have the vertex buffer on it? Surely not. You create it, there's vertex state input, nothing about the buffer that I can see. Is it better to look for vertex buffer? So we jump, jump, jump. There's a bunch of stuff creating it, allocating memory to it, binding the memory to the buffer. This is us mapping it so we can copy data into it, and then we de-in it. So we're certainly not... I still think there's going to be something in here, right? We're not pointing our draw command at our vertex data yet. Assemble primitives are used. Sorry, I forgot where I was in here now. Uses the current topology and vertex count consecutive vertex indices with the first vertex index value equal to first vertex. Maybe that was worth a look then. So if I go back to where I have my vertex buffer creation, presumably in here we must have something. Oh, of course it's just len vertices, because that's something that just lives globally at the minute. So we have draw frame, and then this, we can grab all of that. Vertex count is len vertices, which is probably not a U32. Yeah, so we're in here. Bless me. Cast you to a U32. Right, so our command buffer is now happy. It needs to draw the right number of vertices, which is only going to be 3 for now. More scrolling, endless scrolling. Oh, there's a lot of rules around how you do draws. We just keep going. My God. I feel like from video 1 I've said I should have a look if I can get a concise version of the docs that don't have so much detail in them. Okay, so this is another one with just scroll pi. So this is the corresponding call if we're using an index buffer, which we are not, so we don't care. Jesus Christ, there's a lot of this. Who knew drawing things was going to be so difficult? Okay. We zip back. Conditional rendering, we don't care. Programmable mesh shading, we don't care, I don't think. Aha, fixed function vertex processing sounds like we do care. Vertex fetching is controlled via configurable state as a logically distinct graphics pipeline stage. Vertex attributes, vertex shaders can define input variables. Sorry, I'll have a sip of my drink. So vertex shaders can define input variables, which receive vertex attribute data transferred from one or more VK buffers. By drawing commands, vertex shader input variables are bound to buffers via an indirect binding, where the vertex shader associates a vertex input attribute number with each variable. Vertex input attributes are associated to vertex input bindings on a per pipeline basis, and vertex input bindings are associated with specific buffers on a per draw basis via VK command bind vertex buffers. So presumably, in here we will have a VK command bind vertex buffers. Oh, I can't remember how to trigger completions in this. Okay. Is it tick L or leader L? Show code actions? Oh, there's a lot of this. It's a code lens. Hover, previous. Okay, who cares? Where are we then? So we have the command vertex input attribute and vertex input binding descriptions also contain format information controlling how data is extracted from buffer memory and converted to the format expected by the vertex shader. I think I remembered this and wrote this already. So I think if we go to the vertex, so what is it saying? It has bindings and attributes, and I actually at the time I think even said I don't really get what the difference is. So I guess this is telling us the difference. Vertex shader input variables are bound to buffers via an indirect binding where the vertex shader associates a vertex input attribute, which is these, with each variable, which we can see, right? 'Cause this is us passing through our two F32s, and then so that is in location 0, and then on location 1 we're passing through 3 F32s. The reason for that is in our shaders we have a location 0, which is a 2 component vector, and a location 1, which is a 3 component vector. So that lines up. So those are attributes, and then you have the binding description, which says how it's going to know, I guess, like the format to read these things in at. I think this was about what shader stage was going to read it in. No, it's about whether it's per instance or per vertex, which again, we are doing everything. Well, we're not doing instancing, so we don't have to worry about it. We're using the vertex one. Okay. Vertex input and vertex input binding descriptions also contain format information about how it's extracted. Here, that's what we were just saying. And converted to the format expected by the shader. There are physical limits. Applications can store multiple vertex input attributes interleaved in a single buffer. and use a single vertex input binding to access them. In GLSL, vertex shaders associate input variables with a vertex input attribute number using the location. Cool, this is what we're doing. So we have our location. It tells us how that looks in the intermediate representation. Attribute location and component assignment. Hey? Okay. I think we can probably skim this. We've kind of done it already. I guess we'll come back if we go to draw and just nothing shows up, but I think we've done that. There's probably more detail than we need. What is this? Vertex input description. Applications specify vertex input attribute and vertex input binding descriptions as part of pipeline creation, which, yeah, we've done. Each vertex input binding is specified by this thing that we were just looking at. In fact, I'm still looking at. Byte strive between consecutive elements. Vertex attribute addressing is a function of the instance index. And then this is what we were just saying. So this one then says associating back to these things. So the bindings lined up with this one, the locations line up with what it says in the shader, and then it's telling it how to find different fields by their byte offsets. There we go. To bind vertex buffers to a command buffer for use in subsequent drawing command calls. Which again, do we want to do that? Not inside of here. Why have I said graphics pipeline? That's another to do then. So bind vertex buffer to command buffer here or in init. And again, I think it probably makes sense in init, but let's just do it in here for now. So command buffer is our one command buffer that we are using for all of the things. It's not VK, sorry. So we go to renderer. Command buffer, is it a pointer? It's not a pointer. First binding count. First binding is not a pointer, it's just a number. So let's look. It is the index of the first vertex input binding whose state is updated by the command. A. The binding count is the number of vertex input bindings whose state is updated by the command. What do you mean your state is updated? We're just reading you. And then a pointer to buffers is a pointer to an array of buffer handles. Pointer to offsets is a pointer to an array of buffer offsets. So our offset is just 0. Okay. Maybe this makes it clearer. So the values taken from elements I of p buffers and p offsets, and we know the number that we're going to draw already from, oh my goodness, already from down here. Oh my god, it's just in completion mode. So yeah, we've already specified down here. Oh my god, I've lost it now. There. So our draw command says how many of these we're going to draw. So that's why this doesn't need a length. So this can just take the... I'm guessing these can just be both 0. I'm going to make these 0 for now and see what it says. Binding count 0, first binding 0. Pointer to buffers will be a pointer to renderer dot vertex buffer, which is of type VK buffer, yes. P offsets. Can you be empty, or do you need to actually be a pointer to a thing that has 0 in it? Values are taken from elements I of p buffers and p offsets. Replace the current state the vertex input binding first binding plus I for I in naught to binding count. Okay. My god, that's just not going in. The values taken from elements I of P buffers and P offsets. So we're reading a buffer and an offset, and each of those gives us an element I, or an ith element, and then we replace the current state of the vertex input binding, first binding, plus I. And again, I think we only have the one binding, so ours is just going to be 0 for I in, 0 to binding count. The vertex buffer. Okay, so maybe binding count is 1. If that's the simplest case. And then the vertex input binding is updated. Because otherwise we don't grab any buffer or any set of offsets. So I think we actually are going to need to have a offsets, which will be a, what is your type? VK device size slice with just a 0 in it. And then user are a pointer to that. Is that not how you do this? Nope, because it's a pointer first. So Odin does that way around. All vertex input attributes that use each of these bindings will use these updated addresses in their address calculations for subsequent drawing commands. If the null descriptor feature is enabled, elements of P buffers can be null handles and can be used by the vertex shader. If a vertex input attribute is bound to a vertex input binding that is a null handle, the values taken from memory are considered to be 0. And missing G, B, or A components are filled with 0, 0, 1. Okay, so you just get opaque black if it doesn't know what to do with it. Okay. Alternatively, to bind vertex buffers along with their sizes and strides to a command buffer, you can call this thing. A. Extended dynamic state. So what's the difference? Command bind vertex buffers takes a command buffer, first binding and binding count, buffers and offsets. It just takes sizes and strides. Why is that? This command also dynamically sets the byte strides between consecutive elements within buffer. So I guess the reason to do this is that you could have the single buffer with different things in it. So you could render, let's say in our example, we've got vertices that have a color on them and vertices that don't. We can do all of our ones that have color on them and then dynamically change the state to change the strides to read the rest out, I guess. What are you saying? Unlike static state, set to the same, P strides must be between 0 and the maximum extent of the attributes in the binding. Oi. We may be in too deep, boys. I feel like my head is full. So we're going to ignore it and hope it just draws. We might actually be in a place to just try now, right? So we've got a vertex buffer. We have loaded things into it. We've done no synchronizing. So if it tries to do things out of order, it will blow up. But we've limited it to just draw the one frame, so it can't do things out of order. We bind a vertex buffer that we've copied the data into. We make a draw call. We end the command. So I think if we do all of this, actually, we might be in a place. This might flash triangle. It doesn't flash triangle. It complains. Because we don't have an active render pass. Cool. Must be called inside of a render pass instance. Must be bound with VK bind command pipeline. Cool. Okay. We're going to skim all these bits that sound interesting but not related to what we're doing. Is that actually just going to be like all of it? Derivative clipping, flat shading. Okay. Instead of that, what we might do is we might just do a search for VK command. What was it? Bind pipeline. And we will wait while this... Oh, I thought it was going to take longer. What is this? Appropriate member of these things. What are you saying? Indirect commands, tokenized. Maybe we should have done this from further up the document to try to find the simplest case first. So let's... That sounds promising. Pipeline binding in section 10. What is section 10? Pipelines. Oh my god, it's so far back. Okay, we just missed it. Okay. So once a pipeline has been created, it can be bound to the command buffer using the command. Bind point, specifying to which bind point the pipeline is bound. Binding one does not disturb the others. Pipeline to be bound. Once bound, a pipeline binding affects subsequent commands that interact with the given pipeline type. Until a different pipeline of the same type is bound to the bind point, or until the pipeline bind point is disturbed by binding a shader object. Commands that do not interact with the given pipeline type must not be affected by the pipeline state. And that's kind of all it says. Bind point graphics. Okay, I get what it's saying. So you could bind a graphics pipeline and a compute pipeline and be dispatching both kinds of work. That totally makes sense. We're going to have the same thing. This probably doesn't actually want to live in draw, does it? But I'm going to stick it in draw for now and put a little to do. To bind graphics pipeline in init. Let's do it the same as the other ones. Does it matter if we do this before or after vertex buffers? I don't know. I'm going to do it before, I guess. So command bind pipeline, which will take a renderer. Oops, let's put it in first. So command buffer is renderer. Come on, command buffer. The bind point is dot graphics. And the pipeline, this is when we're going to find out all our stuff on the graphics pipeline that's broken, isn't it? Think positive thoughts. This may be painful. We do that. It can't fail because it doesn't return a result. And I think that was the only flavor of validation error we got. So try again. And another one. What are you saying? Must be issued inside an active render pass. Ah, yes, because we're not... Okay, so the... Oh, sorry, I've just seen the chat. I've been ignoring everybody. I don't know how long ago people mentioned anything. Sorry, I've been concentrating. It is going. We're approaching drawing a triangle, so this may end in tears. There's been a lot of build-up, but fingers crossed. It feels like we're making forward progress. It feels like we're getting somewhere. What was I saying? The render pass stuff is, I think, one of the big blind spots I have, because I've gone through the old Vulkan tutorial, which uses the old version of render passes, where you make them on the graphics pipeline. I think we're going to have to go and find how to do it in this new dynamic rendering thing, because they have put a little disclaimer to say in version 1.4 they've deprecated the old way of doing it. But it means we're now doing something I've never touched before. I'm not really sure where in the docs it's going to tell us how to do that. So I might look for render pass and hope their note about it being deprecated tells us where to go. So hopefully somewhere in here. God, there's a lot of scrolling. Rendering flags. There'll be a deprecation warning in here somewhere because we've seen it before. There will feedback loop. Oh, there must be a better way. What if I search for dynamic? Beautiful. Is there a begin rendering? So that's what we want, right? Is this one? It was added in 1.3. We're targeting 1.3 or newer, so that should be fine. I guess we just wrap all of this. So we need to begin the render pass. I think that can just wrap the draw commands. So if I come in here and I say vk command begin rendering. Yes. With our renderer dot command buffer. Didn't work. Why didn't it work? P rendering info of type rendering info is missing procedure call. Ah, okay, yeah. We will have to go and find that. But we then do our draw. And this is a command, so it needs to be done before we end the command buffer. VK command end rendering. Which doesn't take anything but the command buffer, renderer, command buffer. Right, so now in here, we just need to work out what lives in there. Is there anything that will link me back to it easily? That one's a begin, that one's an end. Okay, skim back. Get rendering area. This all feels promising. Attachment loop. Attachment info. Rendering flag sounds promising. A big valid usage block sounds promising, because I bet there's a lot of rules that you can break in this. Rendering info. Yes, that's what we want. Render pass. Oh god, I should have started at the top. Each render pass instance defines a set of image resources referred to as attachments used during rendering. So we call that, it literally just takes the rendering info. So let's make a rendering info in here, and we can pass it in here. Sorry, so you're going to have command buffer equals that, and then you're going to have what you called p rendering info. Have I done this wrong? Why is it not picking up the names of stuff properly? Should we do a bit of splitting over lines? Doot and doot and doot. And that one is going to be rendering info. Again with the dodgy positioning. So you are going to be a VK rendering info. You'll have an S type because everybody does. Rendering. I thought that would catch it. VK dot rendering info. No, because it needs to be capital. Can I do rendering? Interesting. What actually is it then? Okay. We will scroll to here. You have a struct type, which apparently is not rendering info. Did you mean? No, I didn't mean that. It's going to be something like pipeline rendering info. Dynamic rendering info. I'm so confused. How is this the thing we're falling over at? It's always been the same thing as the type. Okay, do you know what? We're going to give it a wrong one, and the validation layers will tell us what it's meant to be. You're not even the right type. My God, I'm blanking hard now. I'm just getting too tired. What's another one? Are you? No, none of these are the right type. Pipeline. Create. Info. No, that doesn't exist either. If I just look for create. Create. Info. There. Give us one of them. You're also the wrong type. What am I doing? How am I getting this so terribly wrong? Okay, who else has an S type? That. I didn't put the dot. That's it. It's a enum, and I'm not doing the enum syntax. Okay, let's try again. Dot. Rendering info. There it is. Oh, I'm an idiot. Okay. So we've got our struct type. We're going to hope to not need the extensions. We shouldn't need a p next. Flags is always going to be worth a peek. Render area. I think the thing to do might be to comment each of these out and fill them in as we get to them. So we have render area, we have layer count. I don't know what that is. We have view mask, I don't know what that needs to be. Color attachment count. Pointer to our color attachments. And then we're not currently using a depth attachment or a stencil attachment, so I think we can ignore those for now. Right. What are these flags? Rendering contents, secondary, command buffer bits. Is there a nice, there we go. Draw calls to the render pass instance will be recorded in secondary command buffers. We're not doing that. Resuming bit. Resuming an earlier suspended call, we're not doing that. Rendering suspending bit specifies the render pass instance will be suspended. And then we're into extensions. So we are not going to need a flag, hopefully. So, bin the flags. Render area is the render area that is affected by the render pass instance. That doesn't feel like a particularly useful description. What actually is in a VK rect 2D? Oops. It's an offset and an extent. Okay. Do we have a render area anywhere else in the program? We do not. I think we have an extent saved though. So we have the surface extent. I'm going to guess that the offset 0, 0 sensibly just means what you hope it means. And so if I give it 0, 0 and the full surface extent, that what we're saying is we want to render to the entire image. So let's hope it's that. Is it a pointer? It's not a pointer, so I think I should be able to come in here and do VK rect 2D with fields offset equals VK offset 2D 0, 0. Hopefully that works. Oh, we can bin that. It's not a function. And was the other one extent? which we have got saved on the renderer. So let's cross our fingers and hope that works. What would that do if it doesn't work? I don't know. It'll either break or it'll only draw part of what we want. Hopefully the validation layers would catch if it's gonna break. Layer count. I'm guessing. What is this? Is the number of layers rendered to in each attachment when view mask is 0. And a view mask. The view mask indicating the indices of attachment layers. What type is view mask? EU32. So, view mask is the view mask indicating the indices of attachment layers that will be rendered when it is not 0. I have no idea. Is that something about like if you're doing like 3D and you're going to be rendering multiple images for each frame? So I think we can say here we're going to try setting layer count equals 1 and view mask equals 0. Because I don't think the number of layers being rendered to in each attachment, well, we've only got one image out per frame, so I think we're in the simple case. So hopefully that just works for us, and then these color attachments is more interesting. Pointer to color attachment count number of these structs describing any color attachments used. I'm hoping that attachment info is going to make it clear, because I'm assuming we're going to need those for our swap chain images, and that's how it's going to know what it's drawing out to. We're going to need, I think, we haven't got a present command anywhere in our thing, so actually we still wouldn't see a triangle. We're just drawing to the swap chain, we're not telling the swap chain to actually show you anything yet. Okay. Worry about that when we need to. For now, color attachments. Oh, it has loads of stuff on it, including an image view. Sweet. So the rendering attachment info structure is defined as this. So we're going to have one. We're going to have one for the current swap chain image that we're rendering to. Do I need to do something to say, go and get me, like, which swap chain image we're using? Right, because up here we have, we've got our swap chain images, and we've got the image views, so this is what we actually need, and we'll be passing into it. Image layout is the layout of the thing. So I think we're going to have to do some more commands to put the image in the right layout. But so we have multiple swap chain images that we've got available. How do we know which one of those to pass in here on each call we do? Or do we just need another bit of state to say current swap chain image index? I think we might need a bit of state to say current swap chain image index. Can we just use the one? We might get away with just using the one, right? At least in the very first instance where what we're doing is super simple and we're just going to do one frame and bail. I guess just using the one falls over once we have multiple frames in flight. Oh, sorry. Ooh. Okay, I'm going to have in here a Or should we just use the first one each time and see? So we're going to have a swap chain, image, index. I'll make a U32 because that seems to be our default number in what's it land. And I think one thing I'll do then is I'll say at the end of each draw frame, we'll just increment that value. So renderer dot swap chain image index plus equals 1. Okay, so that seems easy. Oh, we can't just do that, can we? Because it's going to max out. Okay. Is equal to its current value plus 1 modulo the length of renderer dot swap chain images. There. We do that now. We can't forget about it. Why can't I modulo that? Mismatch types because it's a U32. Cast to a U32. Okay, so that should work. And so now when we want to get an image, we just use the swap chain image index, and each one should get the next image, whatever that actually means. I think that might be our only attachment that needs to go in here. So we're going to make ourselves... Well, first we're going to go and find the thingy up here with the rendering attachment info. So we're going to say color attachment is defined to be a rendering attachment info with an S type equals not VK rendering attachment info. P next we hope to get away without, and we just did that little song and dance, so our image view will be our renderer dot swap chain image views at renderer swap chain image index. I find it hard to believe that could break. Image layout, I think, is going to take some thinking. Resolve mode, resolve image view, resolve image layout, load op, store op, resolve mode. So what was it? It was resolve mode, resolve image view, resolve image layout, load op, store op, clear value. Right. Why does this feel like it's going to be more difficult than I was going to guess? Okay. So we've grabbed an image view. Image layout is the layout the image view will be in during rendering. Is that something I need to set up? Okay, hang on. So then image layout is that. Resolve mode is a VK resolve mode flag bit value defining how data written to image view will be resolved into resolve image view, and resolve image view is a image view used to write resolved data at the end of rendering. Okay. No, I'm not getting it. So is our swap chain actually our resolve image view? And we just don't have an image view? Is that what that means? Okay. Values in image view are loaded and stored according to the values of load op and store op within the render area and for each device specified in VK rendering info. If image view is a null handle and resolve mode is not VK resolve mode external format downsample bit Android, other members of this structure are ignored. Writes to this attachment will be discarded, and no load, store, or multi-sample resolve operations will be performed. Okay. So if image view is a null handles, there is no image view, and the resolve mode is not this thing, which is Android specific. So if it is a null handle and resolve mode is something else, then these other values get ignored. Okay, so I don't think it can be that other thing I said. So let's see, what are the other resolve modes? None, average, min, max, the Android thing. And then they have a whole bunch of stuff down here. Specifies no resolve operation is done. I think we might have no resolve operation done. So I think we can have resolve image view. Is that the right type? It's not the right type. U1 takes a 0. Yeah, because it's just a number for a handle. Resolve image layout, I'm going to hope is also just a 0. Nope. Are you going to be a nil? I mean, these things are all 0 initialized actually, so we can just do that. And our resolve mode, I do want to set to be none. Oopsie daisy. Which doesn't exist. Because why would it? Average, average KHR. Why can't I say none? I was just looking at it. Is this going to be that thing? It's not a enum, it's a bit flag set. How do I see that? No? Let's do something like that to make it valid Odin code. And then... Really? You're just not going to tell me? Yeah, it's resolve mode flags, which is a bit set. Which means it has to go like this, and then inside of here... There isn't a none. Resolve mode, none. Can I just put a 0 in there? I can't put a 0 in there. I can't put a 0 there. Is this going to be just that none is represented by literally not putting anything? Resolve mode flag, sample 0. That's not the same as none. You have sample 0, you have average, you have min, you have max, you have that downsample Android, sample 0 KHR. Yeah, and then the extension versions. Oh, why are you doing this to me? Okay. These don't even line up though, right? Because sample 0 has been made 0. If that's meant to be these numbers, is it these numbers? No, it isn't, right? Because these ones are all powers of 2. So this must be like an internal Odin representation. Okay. I'm going to plow on and hope that none is just represented by that being an empty set, but I am skeptical. Odin VK bindings have no, I'll say enum value for none. Guessing that is handled by empty bit set. I guess it's not really a to do, is it? Let's call it a note. Okay. Yet again, we don't know, and we're going to just try it and see. I've got a bad feeling that we're going to actually get to the point where it should draw, and it's just not going to work, is it? Image layout is the layout that this will be in during rendering. And then load op is an attachment load op, defining a load operation and a store operation, which we will need. Clear value is a VK clear value structure defining values to use to clear image view when load op is load op clear. Okay, so that's probably the next simplest one. Clear value is a VK clear value. VK clear value is just a color and a depth stencil. So can I say in here VK dot clear value with color equals VK clear color value. VK clear color value, you are going to not tell me what you are. Is it up here? Clear values, clear color value. Oh, it's a union. How do you do unions in Odin? That's an interesting question. You take a... Let's see. Clear color value, which is a struct raw union. All our other things have been floats, so I guess let's do the float one. So you do float 32 to pick which one you want, and then do F32 for make it opaque black. No, because it's Odin, you do it that way around. Maybe. Can you just do that? Because it can infer the type. Sick. That is quite neat. If it works. Although I do want to say in here, what was the other thing? It was a depth stencil. And we'll have to scroll to see what depth stencil can be. Structure, depth and stencil, floating point value, automatically converted to the attachments format. Stencil is the clear value for the stencil aspect of the thing. 32-bit value. Converted. Can I just make them both 0? So can you be a VK clear depth stencil value of depth equals 0, stencil equals 0? Not complained. Has complained. Compound literals are only allowed to contain up to one field equals value element. If I put it inside of this, it's not because I took this out, is it? Compound literal raw unions are only allowed to contain up to one field equals value. It does. Right? Or is it saying it wants the clear value pulled out up here? If I go clear value is equal to VK clear value float 32. If this doesn't work, I think we need to go and check the Odin docs for how you do unions, because I have just made this up. Is that the problem? Unknown thing in structure literal. I've done the wrong one. Clear color value. Looks like that. Is it just complaining that it doesn't like to do can I do, oops, not what I wanted. Problem with not being familiar with the multi-select, you can make a right mess. Color will be clear value. That's still not worked. Okay. Because clear value. Ah, clear value is also a union, is it? Clear value. VK clear color value is a union. Okay, clear value. It's up here. Is a union. Right. It only wants the one. It's not a struct of those values, it's one of those values. Just unions on unions all the way down. And does that mean you can also be a in place, whatever the word for that was? Like that. You cannot assign you to a clear color value. Because you need to be wrapped into all that stuff as well. So actually, yeah, it probably is messy enough that it's worth pulling it out explicitly. Let's just do that. That seems like it works. Okay, let me just check. I think, given it's getting late and I do have work again tomorrow and some other bits to get done, we might have to come back to finish these last details off tomorrow, sadly. Which means we need to go and have a read to work out which image layout to use. We're going to have to have a foggiest idea of how you do load up and store up. So let's do that. But I think if we do those, then we need to go and put it onto our rendering info. And at a very minimum, we also need to do a present command. So that doesn't feel like a bad list to try to hit next time. Out of interest, if I Odin run main, validation blows up, shader output not consumed. It did a thing, but it's not piping it to anything. There is no color attachments. Yeah, so it's what we've been working on. Right, I think that might be our point to just commit everything. We'll say work in progress towards drawing a triangle. In classic Odin fashion, it feels very close, and then you just keep finding more stuff to do. Oh, sorry, I've ignored chat again. Guided tuber. How much setup is needed for Vulkan? Is it similar to Raylib? It's a lot of setup compared to something like Raylib. I've actually never written any Raylib, but I've seen a bunch of stuff with other people using it. If I know right, I think Raylib is kind of a front end. Like they present an API that's very user friendly, and then has sensible default setup, so you can literally just start drawing things. And one of those backends that you can choose to use will be implemented in Vulkan and goes through doing all of this stuff. Vulkan's a lot of setup compared to everything, really. I'm on what now? I'm on episode 8 of, to be fair, very relaxed and casual programming. So I started this stream off saying that it's slightly funny to look back at it and realise that, like, while this is spread out over days and days for me, this is really a working day's worth of effort. Right, like it's not actually that bad, but if you're doing it as a hobby, spread out like this, it feels like it's taking forever. Yeah, Vulkan's a lot of upfront effort. The advantage you get from it is, I think it, in some ways, is much more understandable. Oh, sorry. I mean to set up the software, like downloading compiler, lang bindings, making sure OpenGL is working with the updated drivers, etc. Actually, the Vulkan SDK was very user-friendly to set up. So yeah, on that front, it wasn't a lot of effort. Like I said, I've never done any programming in Raylib, so I don't know what's involved with that. But certainly the Vulkan SDK stuff, I followed their instructions. I checked that VKCube would run, and then I just started writing stuff and it worked. In fact, I didn't even think about like that particularly hard because Odin comes with Vulkan bindings vendored in. So I literally just saw VKCube work, had a go, and yeah, it all just has worked flawlessly so far. and like you can see, I think I've hit the validation stuff, so it's the Vulkan loader is working as intended. I can enable the extensions and layers that I need. So yeah, no, for how complicated it is very slick. I do think it kind of cuts both ways, because I think a lot of the stuff I was doing in the earlier streams with setting up the swap chain and grabbing the surface and picking a device, I think that the ecosystem around that has grown. So if you want to, I think there is more to help you get to the interesting stuff faster. I found kind of googling around it, I was like, I'm already trying to learn something quite complicated. I don't want an entire ecosystem of tools to learn at the same time. Maybe that was me being stubborn. Maybe that is the way to go. So I think, like I say, I started learning Vulkan with the old Vulkan tutorial, which I think totally works, but it's a bit old and outdated now. I think, in fact, shall I have a quick look and see if I can find it? Maybe even tell us who makes it. If you go to VK Guide instead of Vulkan tutorial, did it say who maintains this? I've got it in my head it's Luna G, but I don't know why I think that. But certainly this uses a lot more tools to like get you set up, from what I've heard. I've not been through it all yet. But we may end up having to come back to look at this, because like I say, I'm getting into the point where we're at the kind of like new Vulkan 1.3 dynamic rendering stuff, which I've not done before, and I've heard that this goes through from scratch using all of that kind of method. So if we just get horribly stuck, this is where we'll run to. I'm trying to scan to see if there's something really obvious where they'd be using a tool, but yeah, like I said, I've not been through this, so I can't help. But yeah, it's I think it's probably a good thing if you're working professionally, right? You get a job at id. I'm sure that there's a lot of tools used to keep things moving quickly, because they don't want you spending days plumbing these things slowly together, and then they take the time later to unpick the bits that they need to. Yeah, like you say, I think if you're just learning a thing, then it's simpler with less moving parts, even if it's more effort. Can you pull in libraries like you do in C? As in just import libraries? Like, yeah. So, like, all of the Vulkan imports, like I say, they're vended in, so I've not had to write it all. But these are just imported as, like, libraries, right? So yeah, these guys have written their wrappers around them, so... Oh, I forget, I'm not in near them, so I can't use my normal bindings. Which one of these would it be? Yeah, it's all these imports. I did dig through this and find it. Somewhere they have like a foreign import thing, so you can say that I'm importing this thing, I'm expecting it to follow the CABI. And then, yeah, you could literally just have compiled C libraries that you pull in. So I think they have them for loads of stuff. I've used their STB image stuff before in the Vulkan like vended in library. We're using the GLFW one here as well. It's a slick little thing. I've not tried writing it for my own code yet. I haven't really got very much useful code. I tend to write a lot of sort of useless stuff, just playing around. It could be fun to do. I don't think it's hard. Right, I've read through their docs and it all seemed quite simple. But yeah, it does look like Go. I think I don't know if that's a deliberate choice. The other one that jumped out at me, I recognised the double quote, the double colon sort of declarations. Look very much like Jai, which, like most of the world, I've never written any Jai, but I quite liked the trick that if you're just grepping for a thing, you can find where it's being defined by the fact that, like, where else do you use this double colon, which I thought was neat. But yeah, it does look a lot like Go. They do multiple returns as well, so the kind of error handling often has a very Go kind of feel where, you might return value I care about, error. I think in most of the Odin stuff I've seen, I think people tend to use OK instead of error, because if you come down like so in here, so I'm not really doing any error handling because we just want to see a thing work. So I think everywhere that it could blow up, I've made it panic rather than handle it carefully. But if you wanted to add careful handling, I think people normally come in here and they'd add a boolean like this. And then I think they have an early return thing like this. So you can, if I put it in the right place. So if I come in here, if I do an empty return, that will compile and will work. And the way it works is that this names the return value. So this does the same thing as if I'd taken like, oh, why is it frozen? There we go. If I take that out and just define the types, and then I start the function out with renderer, and an OK bool. Right, it does the same thing as if I did that, and then actually, as a rule in Odin, everything gets 0 initialized. So it's kind of like you did this. And then an empty return would be the same then as if you came in here and put those values in, which it's unhappy with. It's unhappy because everything underneath it doesn't get run. So that's how you would do the kind of multiple return stuff. But because of that sort of, I guess, syntactic choice, where you can put them in here, you can put your early returns in. So an early return will always have an OK of false, which makes it just a little bit quicker to write. I think it's quite a neat little idiom that I've seen in a couple of places. Like I said, I've not done a lot of it yet, so I can't tell you for sure that it remains neat. But I think my knee-jerk reaction to naked returns like that is I don't like them, but that does seem neat, so I'm kind of into that. Similar to Go with no garbage collector. Yeah, maybe. I've not written enough Go to really know like all the ins and outs. Another thing that I think it shares with Go is it does what would the right word be? Kind of modules as directories rather than as files, which I think so we're kind of taking advantage of that. As I've been doing things, I've pulled stuff out. So I think Vertex I pulled out into another file just because I was like, I care about seeing these things quite regularly. Package, yes, that is the word I wanted. So I wanted to be able to see these things really quickly and easily. So I've pulled them out into another file. They're still in the main package though, because like they're in the main directory, which meant that I could move that out from main without having to update any code in main. I can move renderer out without having to update any code. Like they all share a sort of little namespace and can see each other's values. Which again, on first glance, I don't think I would like, but having written a bit of Odin now, and I think having written a bit of Zig before that, I found this much more fun to play with. I could imagine hitting a new code base that you're less familiar with. It feels like things are more spread out and maybe a little hard to see like where bits are coming from, but LSPs are so good that like I think that may be a bit of an imaginary pain now. Like you just jump to definition on the thing and you'd see. But a similar thing in Zig, so I quite like build one big stupid file and then break it up as you need to, right? So I was writing Zig code that same way. It just did my head in every time I wanted to pull a thing out. And now I have to go and update my imports to pull in the new file, and then you have to give the thing a name, and then I have to go update everywhere that's using it. I don't know, it just... It's not bad. If I was doing things professionally, like, maybe Zig's the better language, but for just, like, fun things, I think that kind of, like, lack of friction makes Go very, very appealing. So I tend to use grep a lot if I need to find things. Gives me the function where it's used. Yeah, no, I mean same. So, like I said, I've been using Cocoon a little bit recently, but I'm primarily using Neovim. My God, I don't know what this color scheme is though. I've not got Apprentice installed. Okay, we're using Gruber apparently. But yeah, I find I just like grep around a lot. It's one of the things actually, my kind of requirements for Cocoon to be kind of useful to me is I was like, I need to be able to pull up, I guess like a fuzzy finder for files. I need to be able to pull up grep for file contents within the working directory. And I need an LSP. And if I've got those things, I was like, yeah, I can play with that then. But yeah, I'm the same. I tend to grep for a lot of stuff. But I guess everybody does. Cool. Like I said, I've got to be up fairly early for work tomorrow, so I may bail. But I've enjoyed this. It's nice to meet you, Guided Tuber. Fingers crossed the next stream won't be such a long wait. Like I said, it's been a busy week. I'm hoping to get back on this. I'm so keen to see a triangle come out. So fingers crossed. Next stream we hopefully get there. So yeah, see you next time.